As stated, my name is Micheal Johnston. I work for Hewlett Packard Enterprise. I'm in the Aruba networking division, specializing in ultra-high density Wi-Fi. What is a solution architect? That's a good place to start. They bring us problems that don't necessarily have answers. So we reach into the breadth of products that Hewlett Packard has and try to develop those for you. What we're going to talk about today, both something I love and something I may not exactly love, is smart cities, Internet of Things. I want to start off specifically speaking to the investors in the room. This is a McKinsey report stating that by 2025, the smart city industry could reach up to $1.7 trillion. This is a significant investment that both HP and Aruba have invested in. Primary drivers, we heard in the opening remarks, a lot of the telemetry related data for air water monitoring, adaptive traffic management, these types of systems. What's critically important is understanding where, what types of business drivers are specifically important to all the stakeholders. When we're talking city, we're somewhere in the middle between services and government, where we're equally splitting the load of optimization and risk reduction. However, leaving stakeholders out of these conversations can break your IoT initiatives. So if we look over, for example, in retail, their most important is generating sales. So we need to make sure all these stakeholders come to these conversations. As an architect, the one thing I'm not going to talk to you today about very much is architecture. We think that that is where many organizations miss, is leading with the architecture. So what I'll discuss, what is the Internet of Things? This is the confession of the part I don't particularly care about. IoT has been around for a very long time. We're just now calling it Internet of Things. What are things? Things are, they generate data. Then we have to interconnect these. The network that we interconnect that to creates the context of that data. We'll break that out a little bit more, but traditionally, how is this organized on your traditional network? We have, on the left-hand side here, we have pools of data that are isolated. As we start to use big data engines to pull all this together into what we call data lakes, now, on the right-hand side of the column, we now create ourselves what we call a governance issue. We have this large amount of data, but is everybody entitled to that data? Does a contractor at the port necessarily need access to personal health records? So we have to administrate this very, very carefully as we proceed. Ooh, that went real fast. Okay, so most technology companies stand up here, talk about an architecture. There is no single architecture that can fit your needs. So what we try to do is a concept at HP that we call digital transformation. Start at the highest level with the executive leadership. What do we choose? What do we want to extract? What are our strategic goals that we're going to pull out of this IoT initiative? And then that flow of strategic goals needs to flow and feed and develop what our architecture is. Once we develop the architecture, then we can flow back up to make sure we are meeting all those business needs. IoT, as I stated, it's been around for quite a long time. It does not have a very good track record of success. And this is the reason. Traditionally, it's begun with an architecture. Somebody that has a great technology, and then we have to justify the implementation of that technology. So today, the way we're trying to change this, the way I'd like to position Grand Bahama in their technology revolution is to let's start at the strategic goals. Once we've accomplished that and identified our business objectives, in the green, the middle of this pyramid, we create these business moments. These business moments can be both positive and negative. If we do not execute properly, there will be a distaste for the program we're trying to implement. We won't get adoption to that. The users of the system won't attach to the system, and it quickly starts to unravel the intent of the network. But business moments are those moments in time where the people and the technology meet, and we create revolution, where we create change, we embrace change. So that's really where the focus of our IoT strategy is try to capture those business moments. And that is the exact convergence between the technical and then the executive leadership. So to help us understand what these are, we've created an IoT lifecycle It asks several very simple questions. We'll start in the top half. Visibility, security. Visibility is network connectivity. Does every device that we're talking to need to be interconnected? Because connectivity drives up cost, drives up capital investment requirements. So we need to really understand what devices need to be connected. At the simplest level, IoT is interconnection of everything. But as we try to do this on a Grand Island basis, that may be cost prohibitive in many cases. Then, am I fully protected? Is anybody here fully protected? No. Oh. Well, if somebody were to volunteer, I've been authorized by the VP of Strategic Relationships to give you a year of psychological counseling. So, in today's modern enterprise, it doesn't matter what systems you implement, you're immediately vulnerable. I've heard recently up to 180 days from the time somebody attacks your network until the time you actually recognize that there's a threat. So that's where machine-to-machine AI learning, advanced security to detect horizontal movement through the network. The days of having a nice stateful firewall to protect our network, we need to do a lot more now. So then below that feeds into productivity and profitability. Often these are the business drivers that are feeding our initiatives. Profitability asks the question, am I fully innovating? If I stop innovating, then my technology becomes long in the tooth and it becomes a cost center, no longer a profit center. So we need to continually keep this innovation cycle up. Productivity oftentimes is as profitable as true revenue itself. Are my employees, my users of the system, are they able to access this? In the sports and entertainment market that I work a lot into, what we define fan experience as is IT removing itself from the equation and allowing the fans complete access to use the back-of-house systems that have traditionally been closed to them for years, and they can interact with it. They can have a point-of-sale system deliver a beer to their seat. These types of systems, ticketing, I can upgrade my parking pass without having to contact anybody. I can change seats, trade in, for example, 4 courtside seats for 1 suite. If I have friends coming in from town, and I can do ticket exchange. So these are the types of, we talked earlier in the opening remarks about all these initiatives that we have going on. Consequently, these questions actually are how we develop our architecture. At the very bottom of the pyramid is the devices that are going to be fed into this. Traditional legacy IT, if somebody wanted to deploy video cameras, they would engage IT. We would do a year-long study on which are the best video cameras and DVR encoders on the market. We'd do a pilot project. We'd begin to roll that out. Today, IT gets tapped on the shoulder and says, hey, I have all these cameras. They need to be on the network. So we have to be able to adapt to these devices. No longer is the day of application-specific networking. The network has to accommodate all these needs. So as we move from the digital transformation to actually implementing IoT, we create 3 very unique challenges. Number 1 is vulnerable. How all of these IT devices are built by industrialists whose idea of reliability and availability means it gets locked in a cabinet and no one ever has to touch it for 20 years. That predates cybersecurity that we know of. Many of these systems were never intended to be secure, so we have to somehow figure out how to address that. Where's it at? Clicker stopped. Do we have a manual? Oh, there we go. So, a quick way to explain this problem, it's a riddle of physical devices and an enigma of protocols, and if you're lucky, you have a hairball of security on it. So, there is no, traffic management, these are devices that are programmed via dip switches, right? There is no software on many of these types of devices that we have to integrate into. So how do we take a completely unsecure device and extract secure, intelligent data out of it is the first challenge we have to address. The second challenge is the variety of devices. We don't get to sole source networks anymore and say, I'm only going to put this vendor's equipment on there. Your network has to adapt to technologies and devices we're not aware of yet. So when we build the infrastructure, the answer is how do we incorporate and extract data from apps, analytics, databases, dumb machines, street lighting, these types of applications. How are we able to pull all this into one cohesive network? And then the third challenge is mixing the old and the new technologies. Many old technologies are not even, a lot of the IoT protocols that we're talking about are not even IP enabled. So what technologies and solutions do we create to put those onto our IP-based network? This is one of my favorite graphics here. We actually have to bridge the old and the new. They have to coexist. I would love to tell you that all of the devices that you've installed need to be completely replaced. That's not feasible. And that should not be a part of your IoT strategy at all. So this is where we get into the networking aspect of it. This is, at Aruba, we call it our connect and protect architecture. We start at the bottom of the stack here. We have a very unsecure device. And then at the top, we need secure, encrypted, trusted data out of it. So how do we handle this? What we're actually working our way up through is a series of product suites. At the very physical layer, what are these devices? Sometimes you get to choose those, sometimes those devices are brought to you. Then are they IP enabled? So we need some type of protocol adapter to convert whatever protocol, communication SCADA, telematics, whatever we're actually doing needs to be put onto the IP infrastructure. Then using our ClearPass mechanism, we need to authenticate that device. We don't want somebody to buy a pallet of devices to be able to gain access to your network. Then we have to encrypt that. And then create secure communications between all of our nodes. This is an inherent to Aruba's role-based access for our controllers. Then implement those usage policies. As a user, do I have specific access to these devices? As a device, do I have specific access to these servers? So all these protocols, all these types of securities all have to be outlined, mapped together. And then finally, big data engines. What do we, after we've got everything interconnected, we know everything's secure, what type of business anomalies do I get to extract from the infrastructure that I've just built? So this outlines them in a little bit different of a way. If we look at the upper right-hand corner here, these are the types of infrastructure systems you're most familiar with. I personally like the Aruba one. You'll notice that we've modeled all of our outdoor access points after security cameras. One of the largest concerns we get is that a radio with a bunch of antennas on it looks like a radio with a bunch of antennas on it. So we don't particularly like that. The cost to deliver these solutions with coax connectors, external antennas, those are all points of failure. Water, egress, again, we're working on an industry that's intended for devices to work 10, 20-year lifespans without being touched. So the network needs to have equipment on it that's that ruggedized. Most of our outdoor solutions are installed with a single set screw. We've put a lot of engineering into making sure that when you're hanging something on a street intersection, you have to be traffic management certified, high bucket truck, person on the ground, person on the top. It ends up becoming one of the most expensive places to actually put network infrastructure. But we have to utilize them for all these systems to work. So we have invested quite a bit into making sure that that initial cost of deployment is extremely low for you. Many of the devices also are going to be native to Wi-Fi. This is becoming more and more prominent. We have kiosks that are popping up, the buses themselves. Maybe have a 3G backhaul or Wi-Fi in it, or that's moving around a lot of Wi-Fi clients. So we have to get those onto the network. At the bottom is a lot of our legacy systems. Whether we're going to use broadband over power line, twisted pair, analog RF sensors to plug into. And then, of course, location services now with Bluetooth Low Energy. These are all disparaging types of network technologies that have to be ridden on. And then I talked a little bit about protocol adapters. So a little bit of HP, but a lot of third-party stuff that we actually have to incorporate with. And then at the top left, of course, wired switching, gateway products as well. A little bit more on the gateways. We essentially have two types. We have the EL type of edge-line products. These are very specific to get some type of protocol, telematics, and then put that onto the network. As we move into the converged IoT systems, what we're actually doing now is we're putting analytics and telemetry at the edge of your network. The use case for this would think of autonomous vehicles. All your self-driving cars, autonomous vehicles have a massive data center in the back. They have hundreds of sensors on that vehicle that are being fed, correlating with hundreds of sensors within the cloud that are telling it how to interact. That data has to be processed amazingly real time. So any type of high-level analytics that we need processing power at the edge of the network, we have the 1,000, 4,000 systems. And then, of course, that will bridge all of your IoT solutions and get them onto that kind of second hop. Onboarding. This becomes in the Wi-Fi, this becomes extremely important. Traditional Wi-Fi networking says user has a need, so we're going to give them a VLAN, we're going to give them an SSID and provide security. The problem as we try to scale this is we're only limited to so much Wi-Fi spectrum, and the more SSIDs that we pop up, the more efficient the Wi-Fi airtime comes. So when we're, with what I do in stadiums and arenas, we try to break world records of Wi-Fi utilization. So in order to do so, airtime becomes extremely precious, and so most of our record-setting Wi-Fi networks will have one SSID that we're servicing on a 100,000 seat stadium for guest access. Now on the secure side, we can have So think of the concept of a ticket scanner, where I buy a purpose-built system with a private operating system and a private application. The support of that can sometimes be questionable, but that's a high-dollar system. And I'm hiring a day worker that's not necessarily a full-time employee to operate this, but as I come in, that is the representation of my brand, how that scanner works and how that person interacts with me. If we have onboarding system, we can hire that day worker, make it a requirement that they bring their smartphone with them, give them a card reader, and then that can download the application, securely identify that that is a temporary contractor, and allow them access to that application for the day. So onboarding completely revolutionizes how we bring people on and off of the network. Contractors, very important. If I'm running a network, and I just opened a brand new stadium, and the last day before the grand opening, there were over 3,000 contractors on site. How does one IT person manage all the cards and access? What you do is you can delegate that to the contractor, the person that's bringing them on and off. They can assign those credentials, pull them. But onboarding, it does involve every form of operating system that we have, the access points, and then we need to create certain levels of policy. Can you as a power user access sensitive information from my device, or does it need to be a corporate domain machine for me to access that sensitive? So you have full power and control from a network administration standpoint to delegate those types of rights and assignment. Again, very proud of Aruba's transformation of the outdoor product lines. What you're seeing here was part of Tour de France. I believe it was in Cambridge, in the UK, in Cambridge, I believe. They asked us, can we take your access point and put it inside one of these ballers because this is a historical area? Absolutely. That becomes a very important part of technology. The greatest technology hubs aren't large towers. They're not. The technology becomes quite pervasive and not in your face. So the fact that we can implement this fiber, we can put a fiber adapter immediately inside the mounting arms so that we can extend connectivity basically anywhere. So location services. There's been a very large movement in location services over the last several years. Aruba, like everybody else, was really invested in the Wi-Fi triangulation protocols. There have been quite a few advancements in the mobile device world that have prevented that functionality from happening. For example, it's really hard to triangulate a user when their phone goes into power save mode. So we end up with location services, and if we want to monetize or increase the productivity, for example, are all my security personnel pulled outside of one door, or are they equally distributed? At events like this, security personnel can sometimes be the most costly personnel, so we need to make sure that's there. So to identify which location services you need, we break it down into 3 simple questions. On the far right is a simple, where is this? I walk in, where's my conference room? Can I navigate to that? We can do that via Wi-Fi, or we can do it with location asset taggings now. Projectors in hospitals, crash carts. These very important tags that we don't have seconds to go chase and look for them. We need to know where they're at real time. That's how we do it. Where Am I is the true wayfinding app. We have 2 flavors, a very generic white label. Works great for when really what you're doing is just locationing. So if you think of your typical airport application, finding amenities, these types works great. But for the most part, we've identified that when you are building these apps, most of the time from us, you need our location engine because you're doing far greater, grander development within your app than just locationing. So we can bundle that into an SDK for you so that you're free to explore and develop apps. Where we're at today now is when Levi's Stadium had their Super Bowl. You needed ticketing, and you could gain access to that ticketing through the Levi's Stadium app or through the Super Bowl app. So now we're evolving to where we can nest apps within apps and regain that functionality. And then the more emerging one on the far left is where are they? You may have heard HP's moving from Palo Alto to Santa Clara, where Aruba just opened our headquarters. I've been fortunate enough to spend a whole lot of time there this year. I think we have about a couple of thousand Silicon Valley-based Aruba-only employees that rotate in and out of that building. It's 5 stories. We average less than 700 people a day there, but there's over 150 conference rooms. There's no permanent cubicles. It's a modern workplace. So when I show up and I have a meeting, these rooms may or may not be allocated. It's very, very time-consuming to travel all the floors to try to poke your head into an office to find somebody. So we have our campus app. I share my location. When I walk into the building, if my friends have opted in, we can automatically see where each other's at. If I have that app installed, all of our conference rooms also have tablets onto the front. I can either walk by the tablet and slide it and say that it's booked, or if I leave my phone into the room, after 3 minutes, I get an initiation of a Skype for Business meeting that launches up, books that room within Outlook for me, and tells everybody, find a new room. So the true in-building automation, as a remote teleworker, I have the exact same empowerment of walking in, using AirPlay on my phone up to any projection or any TV and begin my display. I used to give my briefings in boardrooms. Now I actually just walk up to one of the huddle areas and the common areas and give my display at a couch. It's a lot more comfortable, a lot more casual of an environment. And to do that actually involves several more components. So Meridian is what HP Aruba calls our Bluetooth Low Energy app-based locationing. Think of this as a geofencing indoor GPS, extending the GPS. We can get a lot more accurate indoors. As we go outdoors, we tend to rely a lot on, we can do some limited geofencing, but the density we need, we just don't have mounting assets to do real high accurate locationing outdoors. We do focus the use case on the indoor and let the GPS aspect handle the outdoor. And when monetization comes up, almost always when we need to monetize the infrastructure, we need to add in some level of locationing insight. What part of the building are people congregating in? As we talked to challenge number 2, all the multitude of devices. Aruba, we're very standardized. Every single one of our customers almost every one of our customers had a competitor's technology in there. And we can't just necessarily ask them, dump all your investments you've had over the last 5 years with that competitor to buy all this new. For example, in a university, they never upgrade all the colleges at one time, all the dorms at one time. There's a continual rollout always of what's the oldest building, what's the oldest technology, let's upgrade that. So there is always going to be some hangover of old systems, new systems, and we've embraced open standards so we can help bridge that old system as you have the same level of management and security on your aging systems, and then bring that on. And that product that we do all that network management with and visual tracking is a product we call Airwave. Data mining. This is an acquisition Aruba made about a year ago in a company called Nyera. This is our AI, big machine learning, east-west. One of our biggest use cases comes from University of Washington. They have a very large campus, outdoor campus, as you can imagine. They didn't know where to put outdoor access points. If you can think on a very large campus, you may be a kilometer between buildings. That big, large grassy area has no mounting assets. So for the university to invest in putting power and a pole to service that area is a very costly endeavor. So before they went on the lofty goal of putting absolute Wi-Fi, pervasive Wi-Fi everywhere, we're able to turn up a lot of these analytics engines that we have to see where are students actually walking. When at 9:30 when a class ends, are they actually going from point A to point B? So we end up finding anomalies such as the area around the library needs to be the most densely covered because that ends up becoming a hub where everybody's congregating from. And if we can cover that use case, that may solve about 50% of our business needs. Video surveillance. I have quite a bit of experience in this, and this market tends to go up quite a bit when the economies go down. And the reason is that camera and the wireless it takes to get to it are generally cost savings over either wiring a camera or putting a person there to monitor that security. So the key when we do these, we need to have a lot of capacity. We don't build the system to whatever the need of the video is, and I'll explain that why. We need to build that system with plenty of excess capacity. This is becoming more and more as we've built this pervasive citywide, island-wide infrastructure. Now we have public safety concerns that we have to plug into here. Monitoring toxic waste filters, these types. The first one I worked on in the early 2000s was they buried a whole bunch of waste in a rural area and decided to build a subdevelopment community on top of it. So in order for the community to be built, they had to put all these sensors and detectors around so that if at any time a sensor went off that there was a toxic lease, they can immediately reverse the freeways with all the signs and evacuate the town very quickly. Municipal lighting and traffic control. This is becoming a lot more of an important area. Light pollution, where I live in Arizona, I've been told that we have some of the tallest street lights that you'll find. And the reason is we just need that lighting to be right there. We need it for a very specific time or day. We don't necessarily want the city to be this big, bright beacon of artificial light in the area. We like our desert and we like our sunsets. So this lighting, being able to control that becomes extremely important. It's amazing to me how archaic a lot of these systems are to where they just send timers or they manually pull a lot of these public systems down. So turning these on, putting them on the network can actually save us quite a bit of time and money. Kiosks. This is one that even in the sports and entertainment era, we have to accommodate for. So if I'm building a network for 100,000 people, that's great until we get a Super Bowl. And then they push our security perimeter out about a mile, and they light up ATMs, everything. All of these each Super Bowl is very different. There's new technology sponsors that they bring in. essentially the way it works, we get there a month ahead of time and we just start watching where they're putting stuff. There is no communication to us as the network vendor where these things are going to be, what they need to do. Just somebody shows up with 50 ATMs that need to work, and we have to be able to get them on. We're seeing at universities, for example, using kiosks just to drive marketing. The simple concept of putting a photo booth in to collect somebody's email address. You put it in the middle of your campus, people will jump into that photo booth, get 4 of them, and type their email address to have it mailed to them. That helps build income revenues. So we're seeing a lot. Now, with anything that we have to put a credit card into, we need PCI compliance on that infrastructure as well. Unified communications. Aruba's infrastructure is fully Skype for Business compatible. We're one of the largest users for it. If you talk to me on a conference call, that's most likely how I'm talking to you. So once we've built all this capacity into it, we want to leverage this. The mobile data bills are very expensive, especially on large scale if you're looking at the cost for a federal government, for example. So anywhere we have these telemetry devices that have a need for Wi-Fi, we can use Skype for Business, and I use Skype for Business on my mobile phone more than I actually use the call itself. And then monitoring and analytics. After we've got it all, we need to be able to extract if we remember the life cycle, the bottom 2 quadrants. Do I have productivity, and can I generate revenue and make profitability off of this? So as we close out, a couple of the use cases. These are all apps that you're more than welcome to download. Levi's Stadium is an example of our SDK where we're incorporating with a vendor called VenueNext all of the ticketing, parking, point of sale systems. Levi's is famous for being able to have food delivered to your seat without having to get up. Orlando Airport is more of our generic wayfinding app. And then same with Red Rock Casino. And then the far one on the right is the Natural History Museum, I believe. So you can interact with the displays by using these apps. So 4 very different use cases for wayfinding and different ways of how we can implement that technology for your needs. And then while it is very difficult to do a citywide initiative, it has been done. Our most current use case is Cincinnati Bell with Cincinnati. The monetization was actually paid for by advertising. So be happy to have follow-ups later to explain how this was and how those relationships were built to help monetize that system. Oh. There we go. And then for the security and surveillance, for the Beijing Olympics, we had over 50 square kilometers and 600 access points doing physical security monitoring for that. Yeah. So as I wrap up here, how do we get from your strategic goals down to identifying what your IoT architecture is? Again, we bring all stakeholders together, discuss what those goals are, identify the objectives, and then really try to identify what a business moment's going to be for us. What we use is HPE Point Next Services. We call it an IoT transformation workshop or digital transformation workshop. This is very specific to taking executives and explaining how we move from the traditional paper world into a true mobile digital environment. It takes about 2 days to align this specific to your goals. All right, and in summary, there is no one-size-fits-all IoT architecture. If somebody is trying to tell you that, what they've done is created you a solution for a problem that you need to go find. And technology seeking problems never works out well. So the other thing I wanted to close here with is historically, if you dealt with HP and Aruba, I am from Silicon Valley representative, and I appreciate the opportunity, but we do now have a dedicated Latin America, Caribbean team, so I'm more than happy to connect you with those folks to help give you that local support and local presence. All All right, thank you everyone, I appreciate it. Thank you.